Hey everyone, have you done the homework that I gave you last in the last session? Tell me in the comment section now. Okay, Saksham, if you didn't do the homework, actually, are you talking about the homework? If anyone hasn't done it, please do it. I think I will have the next class on Tuesday, I guess. So do it by then. So what we are going to do today is last time what we did was okay. Let us see who remembers what we did in the last session. Tell me in the comment section what we did in the last session. Anyone who remembers what we did in the last session, tell me in the comment section. No one? So last time what we did was we proved how to prove a number to be irrational. Do you remember that? We assume it to be p by q. We square both the sides and then we substitute the values. Then we prove that the p and q are not co-prime. Hence our assumption was wrong. So today what we are going to do is two things which are almost similar. Yeah, right. You are right. Two things basically which are like almost the same. Euclid's division lemma and Euclid's division algorithm. And one more rule we are going to do. So let me share a screen. Yeah. So first, let us do the rule first. Wait a minute. So if I ask you which numbers are terminating and which are not terminating, what are you going to say? No, section, we are not talking about the lemma yet. Basically, terminating numbers are those numbers which get fully divisible by a number like even after decimals. For example, take 5 by 2. The decimal expansion is 2.5. If it is fully divisible, even no bothering about the decimal point. If it is divisible, we call it to be terminating. Those are called terminating numbers. And now in the non-terminating case, there are two cases. Further two cases are there when the number is non-terminating. Non-terminating, we have first case is non-repeating. Second one is repeating. Wait a minute. Second one is repeating. And here we have non-repeating. So in the non-repeating case, whatever the decimal expansion occurs, say we divide a number by any other number, like first of all we have a case in which the numbers get repeated, like for let us take a decimal expansion which is 0.6666666666. In that case the decimal expansion is repeating to infinity. In every time you divide it you will get 6 only, and that is called the repeating case. And wait a minute, we represent it as 0.6 bar. Actually this bar sign is called vinculum. That's a single bar actually. Or you can say 0.4 bar. Fine. That is called the vinculum. So are you aware about this sign or not? Tell me. Are you aware about this sign or not? Yeah, that is called vinculum. Have you heard of the term yet about that bar thing and converting that to rational numbers or not? Tell me in the comment section. So this is called bar. These are called repeating. And all the numbers whose decimal expansion is repeating, those are rational numbers. And whose decimal expansion is non-repeating, they are called irrational numbers, obviously. Non-repeating, for example, you can take take it to any extent, the decimal expansion will be non-repeating. Example 0.10110 110 further on. Okay? Because I'm explaining side by side. So those are called non-repeating numbers. Now, what we categorize as rational numbers who are terminating, and secondly, whose decimal expansion is repeating. Both of these are rational numbers, and whose decimal expansion is non-repeating, they are called no, irrational numbers. Now, whose let us take an example 17 by 10. Yeah, tell me 17 by 10. Is this terminating or not? Tell me if it is terminating or not. Fast, in the comment section. Is 17 by 10 terminating or not? What do you mean by terminating? It is fully divisible after or before the decimal. Okay, tell me. Yeah, Lavanya is right. It is terminating number. Only Lavanya got it right, yet no one else answered. So 17 by 10. Okay, prime factorize the 10. What we get? 17 upon 5 into 2. Fine. Okay, let's take another number. Let us say Let us say like any number, 62 upon 35. Tell me if it is terminating or not. Okay, Bintu. If it is terminating or not, tell me. Now, you don't have to divide it further on, like just keep on dividing and dividing and dividing. What you have to do is just factorize the denominator. Now, if we factorize the denominator, what do we get? We get 62 upon 5 into 7. Right? Now, have you seen a difference in the last number? Bintu, no, it's not terminating. Yeah, Lavanya is right. It is non-terminating number. Let me tell you why. So basically, it is a rule that any number which is terminating has to be of the form. Form is a number is x upon the denominator has to be of the form 2 raised to the power m multiplied by 5 raised to the power n. That simply means that the denominator has to be a factor of 2, either 5, or both. Is that clear? Tell me if there is any doubt. We'll practice it further on. Just tell me if there is any doubt till now. Any doubts? Yes or no? Tell me in the comment section. Guys, be active in the class. Yeah, denominator should be not 2 or 5. It should be a factor of 2 or 5. Sorry, the factors should be of the form 2 or 5. Like 2 could be raised to any power, 5 could be raised to any power. Fine. So, okay, let's ask you a question. Tell me if 65 upon 130. Is it terminating or not? Is it terminating or not? Any answers, please? 65 upon 130. Is it terminating or not? Oh, actually. Lavanya, just tell me the answer. Yeah, Shrejan is right. Terminating. First one to answer. Let me tell you why it is terminating. See, whenever you are checking if the denominator is in the form of 2 raised to power m into 5 raised to power n, firstly you have to convert it into simplest form. See, 65 and 130 are co-prime or not? Tell me. 65 and 130, are they co-prime or not? You know the meaning of co-prime, right? No one, there should be no common factor. Tell me if there's any. Fast. If they're co-prime or not, 65 and 130. Let me tell you. 65 into 2 equals 130. So they are not co-prime. First of all, what you have to do is convert them into co-prime numbers, which is what you get. Equal to 1 upon 2. So see, now tell me, is 1 by 2 terminating or not? Hi Harshit, you missed a bit. No worries. Okay, Shrijan, no. Anyone else? Harshit, no. Lavanya was there. Tell me if it is terminating or not. Is 1 by 2 terminating or not? Now let me tell you, it is terminating. Harshit, no worries because students can see the replay as well. So like some of them may be busy right now. See, I'm telling you that 1 by 2 is terminating. Yes, it is terminating. Because see, can't you write 1 by 2 as 1 upon 2 raised to power 1 into 5 raised to the power 0. Can't we write it as like that? Because any number raised to the power 0 is 1 and any number multiplied by 1 is the number itself. So we can write the number to be 1 upon 2 raised to power 1 into 5 raised to the power 0. Yes or no? Tell me in the comment section. Yes or no? We can write it like that, right? So that's the reason we call it to be terminating. See, let's count on the steps. Write a number, convert it, both of them into co-prime, cancel the terms, right? Convert into co-prime. Second step, what you have to do is factorize the denominator. You have factorized the denominator after converting them into co-prime. That is a must to convert them into co-prime, or else you may get the answer to be wrong. Second step, convert them, factorize the denominator. Third step, check if there is a factor except for 2 raised to power m or 5 raised to power n. Let's take one more example. Let the number 2 be 3 and 130. Now tell me if it is terminating or not. First, tell me, is 3 upon 130 terminating or not? Okay, Bintu, yes. Yes. Yeah, it is. Any answers, please? 3 upon 130, it is terminating or not? ASAP. Yes or no? Tell me in the comment section. Okay, let me tell you. It is not. It is non-terminating. See, let me tell you first. 3 upon 130. 3 and 130. Are they co-prime? Yes, they are co-prime. They do not have any common factor. So just we'll go on to factorizing the terms. What we have here? 13 into 5. 13 into 5 into 2. See, we have the numbers 5 into 2, but we should not have any other factor. Here we have 13 as another factor, so we call it to be non-terminating. Is that fine? Is it clear to everyone? Bintu, that's not terminating, because we should not, like, it should be only of the form 2 raised to power m and 5 raised to power n. There should not be any other prime factor. Here we have 13 as a prime factor, so it is non-terminating. Now tell me in the comment section if it is clear or not. If there is any doubt, you can tell me. Be frank to ask doubts. Any doubt till now? Okay, well, go on. Wait a minute. Give me a second. Yeah. So now we know all the rule that the number should be, the denominator should be of the form 2 raised to power m into 5 raised to power n, and plus there should be no any other prime factor except for these. So we are through with it. Now let's come to a new term which is very new to you, and it is in the 10th class syllabus, which is Euclid's division lemma. And now what do you mean by Euclid's division lemma? See, you know the simple dividing part, right? How to know how to divide. Let's take two numbers, like any two numbers. Let it be 2 and 15. Simple numbers, right? Let 15 be the dividend and 2 be the divisor. So while dividing, what do you do? So what do you do? We'll write here as 7, 14, subtract, and 1. Now, do you guys remember earlier in school days what our teachers told to do was verify if it is true or not, right? So what we did when we verified, what we did was keep the dividend here and keep it equal to divisor into, now this term, what we called it, this is called quotient. This is called quotient. So we multiplied it by quotient and then add the remainder, which is 1. So what if I tell you that's all the lemma says? Like simple, right? What what does lemma does? It just writes it in a statement form. Let us do it. Right here. Any number C. What does Euclid's lemma do? It just writes, okay, then I'll write fast. It just writes the division method, like when we divide the simply what we divide two numbers and what we get as question, and when we verify it. It just writes it in a statement form. Plus, what it does is it adds one more condition to it, which is that the remainder, which is R, can either be can be greater than or equal to 0, and less than or not, it's just less than b, not equal to b, and less than b. That is a condition. So why do we use this Euclid division lemma? Basically, in your NCERT books, what we use it for is to find out the HCF. It is a method for finding the HCF. Now, what about Euclid's division algorithm? Like, don't these both of the terms, algorithm and the lemma, Euclid's division algorithm and Euclid's division lemma, don't they sound like similar? Okay, just tell me what is algorithm. Tell me meaning of algorithm. Tell me if you know it or not. Yes or no. See, what do you mean by algorithm? Algorithm is a way of doing something step by step. Algorithm is the procedure of doing something. And lemma was just a statement which specifies the rules when you divide and what you get. Right? Lemma means what when you divide and what you get. And what do you mean by that algorithm? A sequence of terms, a sequence of steps of the procedure what you use. Right? So algorithm is nothing but the application procedure of the lemma. So if you have your NCERT books side by side, if you have this book side by side, then we'll discuss the examples and your exercise is your homework. In exercise, first is there are many questions related to that. So just take a simple example. On page number 5, you have an example, which is Use Euclid's division algorithm to find HCF of 4052 and 12576. Now you must be thinking, how can we use it to find HCF? Let me tell you. What was our Euclid's division algorithm? Lemma, sorry. A equals BQ plus R, right? So we are going to use that only to find the HCF. Let us see how. See. Wait a minute. What you're going to do is, first of all, write the number. Which of these terms is larger than the other one? Which one of the terms is Bintu, just now I told the difference, which is C. What is lemma? Lemma is just a statement of like when what you do when you divide. Just take two numbers A and B. When you divide, what you get? A quotient and a remainder. So it's just and remember when we verified when we were in preschool when the teachers taught us how to divide, they told us to verify the steps. So what we did when we verify dividend equals divisor into quotient plus remainder. That's what we did. So what we did was what the lemma does is just writes it into a statement form in a statement form, and it adds one more condition as well, which is the remainder can either be equal to 0 or greater than that. Also it should be less than the divisor. That is a statement which lemma satisfies. And what is the meaning of algorithm? Algorithm means sequence of steps which we use to follow a procedure. Basically, what we used a lemma for is to find the HCF in your NCERT books. There are many uses as well, but what we use for in the book is to find the HCF of two numbers, or you can say three numbers as well. So what you do is take the number, we find the HCF, and the procedure, the steps we follow, the sequence we follow, that is called the algorithm. So they are like almost a similar terms. So what were our terms? 1, 2, 576 and 4052, right? So which one is greater than in both of these? Which number is greater than the other in the both of the terms? Tell me in the comment section. Any reply? It's a simple question. Tell me which of the numbers is greater, 12576 or 4052? Obviously 12576. 12576 is the answer. So take the larger greater number to be the dividend. So what we write here? 12576 equals, now divided by 4052. Take it to be the dividend. 4052. So when you divide, what comes out to be the quotient? If you have the NCERT books, that's well and good, because that's better. If you do not have, you can open the PDF side by side. Sorry. Into 3. 3 comes out to be the quotient, and the remainder is 420. Any doubts till now? Any doubts? Are there any doubts? Okay, then I'll move further on. So what do you get? Like simply what when we verify the term, we take the dividend equals divisor into quotient plus remainder. That's what we did. Now in the next step, take this 405 to be the dividend. This 4052. And you have to keep on repeating this process unless like till you get the remainder to be 0. Now take 4052 equals, now you are dividing it by the remainder you get in the previous step. So let's take the first step, 12576 equals the dividend divisor, which is 4052 into quotient we get 3 plus remainder what we get is 420. Now take the previous steps divisor is the dividend in the next term. पिछले स्टेप का जो डिविजर था वो नेक्स्ट टर्म का डिविडेंड बन जाता है. नाउ और जो पिछली स्टेप का रिमाइंडर होता है वो नेक्स्ट स्टेप का क्या बनता है? इट बिकम्स अ डिविजर. सो व्हाट वाज द रिमाइंडर इन द लास्ट स्टेप? इट वाज 420 and when you divide it, what do you get as quotient? 9 and the remainder comes out to be 272. So again we repeat the process. Take 420 as dividend. 420 equals take 272 as divisor and quotient comes out to be 1 and the remainder comes out to be 148. Still we haven't got the remainder to be 0. Again we'll do the process again, which is take the dividend to be 272 equal to what was the remainder in last term? 148 into 1 plus what is the remainder? What we get is 124. Wait, we'll start from here. See now. Last term's divisor 148 equals last term's remainder 124. When you divide, what is the quotient? 1 and what's the remainder? 24. Still the remainder is not 0. Do the process again. 124 equals 24 last term's remainder. Wait. 24 into 5 and what do you get as a remainder? 4. Still the remainder is not 0. What do you do? Last term's divisor 24 equals last term's remainder 4 into 6, which we get as quotient, plus finally what is our remainder? 0. Now in this step we get the remainder to be 0. So now see what is the divisor in this last step. 24 equals 4 into 6. What is the divisor? Which is 4. So we come to the conclusion that HCF of 12576 and 4052 equals 4. Whatever the divisor you get in the last step is the, no doubt, whatever divisor you get in the last step is the HCF of the numbers what you were finding. So tell me if there's any doubt. Any doubt? Oh, Vinayak here. So Vinayak, do you know what we did till now? Tell me in the comment section. Do you know what we did till now? And the students who were present, tell me if there's any doubt till now. Whatever the divisor you get in the last step is the, yeah, the answer is 4. Tell me if there's any doubt. Any doubts? Fast, fast. No doubt. Fine. So, and like whenever you are writing, you have to just enter a bracket over there and you have to write by Euclid's division algorithm. That is a must. Yeah. So what you're going to do is do the exercise 1.1 today. Again, that's a homework. And there are some, like one more type of questions, which I'm going to show you now. Which is show, like if you have the NCERT book, you'll know that. Wait a minute. You'll know that the on the page number 6, example 2. What is the question? Show that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1. See, what our Euclid's division lemma states is a equals bq plus r, and where r is greater than or equal to 0 and less than b. So I take an assumption that that the b is 0, b is 2. Okay, and I'll take the question to be q. And what possibly the remainders can you get? R equals 0 or 1. Now, how did I arrive to this condition? See, I told you there's a condition that the remainder can either be equal to 0 or greater than it and less than the divisor. Now, we took the divisor to be 2. So, first condition we have is the remainder can be 0 and less than b. And now don't tell me that why can't we take it to be 0.5 or something, because they have to be integers, right? So we have our case 1 here. Wait. Case 1, r equals 0. So if r equals 0, substitute the values. A equals 2q plus 0, right? Now we have to prove that every even integer is of the form 2q. Okay, if a number has to be even, it must be divisible by 2. Is it divisible by 2? 2q, is it divisible by 2? Yes, it is divisible by 2. So, see, when you are taking a divisor to be 0 or 1, every number can be represented of the form. See, अगर हम कोई भी डिविजर ले रहे हैं और उसके रिस्पेक्ट में जो भी रिमाइंडर मिल रहा है, तो अगर आप उस फॉर्म में लिख दोगे तो कोई भी नंबर उन सारी फॉर्म्स में से फॉर्म हो सकता है. अगर डिविजर आपने 2 लिया तो कोई भी नंबर ले लो, वो या तो 2q की फॉर्म का होएगा या फिर 2q प्लस 1 की फॉर्म का होएगा. बताती हूँ. केस 2, r equals 1. हर नंबर इधर किस फॉर्म का होएगा, 2q या फिर 2q प्लस 1 का. बस हमें इतना प्रूव करना है कि what the number we have over here is like every even integer is of the form 2q and every odd integer is of the form 2q plus 1. We when we put r to be 0, what we get is a equals 2q, and 2q is obviously divisible by 2, so it is even. Now when we take r equals 1, a equals 2q plus 1, right? So is it divisible by 2? Tell me if it is divisible by 2. No, it's not divisible by 2. 1 will be remain as a remainder. So the numbers which are not divisible by 2, those are odd. So what you're going to write is, then prove that every even integer is of the form 2q and every odd integer is of the form 2q plus 1. Any doubts still here? Tell me. Any doubts? Sorry. Yeah, you're right. It's odd. So we have proved that every number, मैंने क्या बोला था, किसी भी पर्टिकुलर कंडीशन में अगर आप कोई भी डिविजन लेट करते हो और उसके रिस्पेक्ट में जो रिमाइंडर्स आते हैं, वो रिमाइंडर को जब हम दोनों वैल्यूज को सब्स्टिट्यूट करके जो केसेस बनते हैं, तो हमारे क्या केसेस बने, 2q एंड 2q प्लस 1. सो वी कैन चेक कोई भी नंबर होएगा, लेट इट बी 13 और 14 और 15, it can be represented in the form of 2q and 2q plus 1. Either 2q or 2q plus 1. We can represent it in the form of that. So, we just have to prove कि जो 2q है वो टर्म सारी इवन होंगी और जो 2q plus 1 है वो सारी टर्म्स ऑड होंगी. तो वो हमने प्रूव कर दिया. 2q is divisible by 2. Yeah, so there's no doubt. So, we have covered the topics which we had to do. See, there are some questions. Exercise 1.1 which you have to do, and the examples till that which are till example number 4. You have to do all those examples and tell me if you have done those, and that's a must because you won't do it then that won't be helpful to you just to know it. See, in maths सिर्फ थ्योरी जानना इंपॉर्टेंट नहीं होता. फॉर ए सेकेंड आपको लगता है कि सारा समझ आ गया, कोई जरूरत नहीं प्रैक्टिस की, बट जब तक आप उसको प्रैक्टिस नहीं करते उसकी, आई गारंटी यू 3-4 दिन में आपका जो कॉन्सेप्ट क्लियरेशन था वो गायब हो जाएगा. फाइन. सो दैट वाज इट. जो हमारे टारगेट टॉपिक्स थे आज के कंप्लीट हो चुके हैं. सी यू इन द नेक्स्ट सेशन. या आई एम क्लोजिंग दिस सेशन.